Okay, topic 25 is all about pyramids and cones, oblique pyramids, oblique cones. In this lesson, we are going to talk about what they are and then be able to find the volume. Okay, so for question number 1, it says to find the area and perimeter of each regular shape below. So we're going to have to use the formulas for area of a polygon, a regular polygon, which is what we have for A. And if you'll remember, that is the area is 1/2 the perimeter times the apothem. Okay. So what they've given me in this hexagon is the side length. And if you'll remember, the side length and the radius in a hexagon are congruent. So if the side is 12, then the radius is 12. That makes this side 6, and that's the short leg of that 30, 60, 90. And so then the long leg would be 6 square roots of 3. So we've got our apothem now, and we've got the side length so we can find the perimeter. So this has 6 sides. So the perimeter would be 12 times 6, which is 72. And then to find your area, you're just going to plug in the apothem and your 72. So area is equal to perimeter, which is 1/2 times the perimeter times 6 square roots of 3. And we're going to leave this in radical form. So we are just going to multiply. That's 36. Half of 72 is 36. Times 6 is 216. So this would be 216 square roots of 3 meters squared. Now for the triangle here, we can use this same formula. We've got 4, so we can find the perimeter, but we can also use 1/2 base times height. And so that's probably what I'm going to do here, because I think that's what most of you would do. The perimeter, though, because it's asking us to find the perimeter, is 4 times 3, which is 12. So 12 feet would be our perimeter. Now, to find your area, I'm just going to do 1/2 base times height. And so the base is 4, and then this is my height. And this triangle is a 30, 60, 90, because it was equilateral. And so this side would be 2, just like we did here. This is 4, and then this would be 2 square roots of 3. So to find my area, my base is 4. That's this side here, this whole thing. And the height of the whole triangle is 2 square roots of 3. So half of 4 is 2. 2 times 2 is 4. So 4 square roots of 3 square feet would be my answer. Now we're going to need this in order to find the volume, and even if we were finding the surface area of pyramids, and because pyramids can be different, we can have different pyramids. They all depend on the base, the shape of the base. So you've talked about pyramids. You've seen them before. A pyramid, like a prism or a cylinder, it says is a geometric figure that extends beyond a single plane. A cone, like a cylinder, is a three-dimensional figure that extends beyond a plane. And so here, kind of a picture of a cone. So in this animation, we're going to look at how they're different, though, than prisms and cylinders. And then that's going to change the way we find our volume and our surface area. So here is a pentagon, okay? And we did this before. We started with a plane. Now, if we put a point just not on that plane and connect all the vertices to that point, we are going to get a pyramid. Okay, this is a three-dimensional figure, It has one base. That base is what determines the name of our pyramid. So this would be a pentagonal pyramid. The vertex is where the edges meet, that point that is not on the base. These triangles, and with a pyramid, your lateral faces are going to be triangles, just like in the rectangular prism, or even in any prism, the lateral faces were either rectangles or parallelograms. So these are going to be triangles. Where the lateral faces meet, that is a lateral edge. And where the base and a lateral face meet is called a base edge. And then your altitude is the segment that connects the vertex and is perpendicular to the base. We have different types of pyramids. We have right regular pyramids. So a right regular pyramid means that the vertex is centered over the center of the polygon. You can see that, and we're going to put this, add this to your notes, and we're going to come back to 2 through 5. So we're going to put that this is a right regular pyramid. And then this is an oblique pyramid. And the difference is the altitude is still perpendicular, but it does not connect the center. The center of that polygon is not what is connected to the vertex like it is here. Okay, so we're going to, if you'll write down, I'm going to pause this for a second. I want you to write down the what is listed here on number 6 right here. All right, something else that we need to talk about in a pyramid is what we call the slant height. So the slant height is the altitude of each of the lateral faces. So if we just look at the triangle, so picture that you're at the top of this pyramid and you're going to slide down. That slanted segment is what we call the slant height. And it's going to be perpendicular to this base edge, and it's going to connect the vertex, but it's the height of this triangle, okay, not the pyramid. It's the height of this lateral face, this two-dimensional figure right here, this triangle. Okay, so let's go back to this on number 2, okay, and it says, how many bases in this do you see in this pyramid? So in our pyramid, we have one base, and we're going to name it, okay. We're going to say, let's see, we'll start with B. B, C, D, E, F is going to be our base. Your lateral faces are the triangles. So since this is a pentagon, the base is a pentagon, that means you're going to have 5 lateral faces. So you've got 5 of them. And it's the triangle, so just name one of the triangles. So triangle, we'll name the one in the front, ADC, which is this one that's right here. Your lateral edges are the segments that connect the lateral faces. So from the vertex to the vertex of the base to the vertex of the pyramid. So there's 5 of them. And we can say segment AD is one example. And then your base edge is the segment that joins the base and the lateral face, so like ED. So we've got 5 of those also. And then if it said, like slant height, each of these, if this is a regular pentagon, then each of these would have the same slant height, as long as it's a right regular pyramid. If it was not, if this base was not regular, so these side lengths were different, then each one would have a different slant height. So that's important when you're finding surface area. All right, let's look at cones. Okay, same thing with pyramids. Cones can be right or oblique. Okay, a cone is its base is a circle instead of a polygon. So we're going to put same thing here, right cone. And the altitude, you'll notice, is perpendicular at the center of the circle. So if you connect the center of the circle to the this vertex that's up here, they're going to be perpendicular. So the altitude is perpendicular to the base at the center of the circle. Okay. An oblique, the altitude is still going to be perpendicular because that's what altitude is. It's just not going to be at the center of the circle. It's going to be at another point. All right, so let's talk about how pyramids are different than prisms and how cones are different than cylinders. So here is your 4 different solids that we've been talking about. So notice that in a prism that you have your bases are parallel to each other. So you have 2 bases. Same thing with a cylinder. You have 2 bases. But in a pyramid, in a cone, we only have 1 base. So that's how they're different. They're different than prisms and cylinders because they only have 1 base. But these 2 are similar in that their bases are polygons, and these 2 are similar in that their bases are circles. All right, so let's talk about this piece of chocolate right here, this chocolate candy. So we're back to designer. She's got this piece of chocolate that is in this shape. And our question says, what is the correct name for this geometrical shape? So look at this. We have 1 base, and that base, because this is 4, 4, 4, and 4, our base is a square. So we would call this a right square pyramid. Right, because the altitude is in the center of this polygon connected to the vertex, so that makes it right. And the base is a square, so it's a square pyramid. All right. So let's talk about the volume of a pyramid. How are we going to calculate the volume of a pyramid? I'm going to go ahead and stop this and start a new video.